Hello everyone, my name is Liu Junyan from MAT201 and my student ID is MAT2409020. Today I'm going to talk about the uniqueness of the limit in the mathematical analysis series. Let's first look some big idea. In the analysis, we know that converge implies some series that get close to some number. Just if a sequence an get close to L, this means that the sequence an also identifies with L. So I have the question about, can a sequence just identify with two different numbers at the same time? So we just do that question below, and we first know the definition of the limit. From the definition, we can write it in the mathematical way. For all epsilon larger than 0 that exists and n belong to natural, and for all n larger than n implies that an minus l smaller than epsilon. So we can do some transform for the an minus l absolutely smaller than epsilon, so that we can just cancel the absolutely, so we can find the an is always in the interval. An is belong to l minus epsilon and l plus epsilon. An is in the interval. We just use the interval to do the proof. Then we talk about the series. If a sequence an converges to L when n converges to infinity, an goes to L, n goes to infinity, an goes to m, this implies that L is equal to m. This series tells me the answer of my question just now. So a sequence cannot converge to two different values at the same time. L must equal to m. So let's think about how can we prove that. We just draw the picture about the an's interval. We know the an is belong to the interval if the sequence an is converged to L. If limit an equal to L, we know that an is belong to this interval. So we can write down something, because limit an is L and limit an is equal to m, we can know that 1, an is in the interval L minus epsilon, L plus epsilon. 2, an is belong to m minus epsilon and m plus epsilon. So we can know an is in the neighborhood of L and the an is in the neighborhood of m. So we just jot it down like this. So we found that an cannot in the two different interval which is disjoint. So we found the idea of the proof. But why should we find the disjoint of neighborhood of L and the neighborhood of M? Let's talk about that. We just choose the epsilon is large enough so that the neighborhood of L and the neighborhood of M is disjoint. We just do that. Draw the neighborhood of L like this, and the neighborhood of M M is there. So we found it is possible that exists some an in this way, in this interval. An is in this interval so that it both in the interval of neighborhood of L and in the interval that satisfy the two interval. So we want to find some contradiction, so we must choose the epsilon to be more smaller so that the two neighborhoods are disjoint, so we cannot find an in both neighborhood of L and M. So we know the idea of the proof. We just write it down in the mathematic way. We just write the definition down first. Write down the limit, definition of the limit first. In this way, like 1 and 2. Since we are proved that in the contradiction, so we first, of course, we need to assume L is not equal to M. Then, since by the definition, we can know that for all epsilon larger than 0, it satisfies something. So we can choose the epsilon. But how can we choose the epsilon that we can satisfy the proof we want? So it is something we need to compute in the following. So we then choose the n is larger to any one of the large n1 and large n2. So the following we can use 1 and 2 both in the following compute. Then we use the absolutely series. We write the L and the M down and plug the an minus an and plus an here, and then use the absolutely series so that we can find the L minus M absolutely is less than 2 epsilon. So we choose the epsilon to be L minus M absolutely over 2. Then we can find some contradiction because L minus M epsilon is equal to L minus M epsilon. So we can finish the proof. Then let's apply that by some very simple example. We just prove the sequence an equals to -1 to the power of m is diverge. We can know that an 2k is equal to 1, an 2k is -1 is -1. So we can know that the even term and the odd term is not the same. So we can write down the limit of them. We can write limit of them. My bad. I need to write down the k is not is equal to 1 and limit k equal to infinity. A 2k minus 1 is -1. So we can know that the limit is different. By using the uniqueness series, we can know the limit cannot be two different numbers, so that we can know that it's some trouble here, so the converge is not possible, so it's diverge. This is all of my part of uniqueness of the limit. So thank you for your listening, and I hope my video can help you. Thank you.